Hello, everyone, and thank you for joining us for Fast Forward, lightning talks on the subject of innovation in technology. My name's Paul Graham, and I'm a lead developer at ScottLogic. ScottLogic is a technology consultancy that builds diverse, bespoke software solutions for our clients. Everything from complex trading platforms for investment banks and open banking with NatWest to a payments platform for the Scottish Government. We have offices all over the UK. I'm based at our head office in Newcastle, and I host our internal Tech Talks events, where we invite our colleagues to share their passion for technology so that we can inspire and learn from one another. When digital leaders invited us to take part in Innovation Week, I thought I'd ask some of my colleagues to share some of our recent talks with you. I hope you enjoy them. We'll get started with COLIN EBERHARDT, our CTO at ScottLogic, who is talking about the latest innovations in AI-powered pair programming. Over to you, Colin.
Thanks, Paul, and I'm very glad you enjoyed the tongue twister for a title. My apologies for that. I'm not going to say it again. Okay, so GitHub Copilot, if you haven't heard about it already, I don't know what rock you've been living under, but just in case, Copilot is a tool that's been provided by GitHub that provides code suggestions within Visual Studio Code. Now, this is something that we've been able to do for many years with things like autocomplete and so on. However, GitHub Copilot takes it to another level. Rather than just auto-completing variable names, it gives you suggestions for whole lines of code or entire functions right within your editor. It came out in preview release a few months ago amid much uproar around licensing concerns, and we'll briefly touch on that in a little bit. As soon as I saw this preview, I signed up and I was lucky enough to gain access to the beta, and that's what I'm going to share with you today. Now, in terms of how you use it, it's incredibly simple. GitHub Copilot is installed just like any other Visual Studio Code extension. You go to the marketplace, you click the install button, and off you go. GitHub Copilot then effectively programs alongside you, giving you suggestions as you type. Now, I'm going to give you a little bit of a demonstration, but before I do that, I want to talk a little bit about the technology that powers Copilot. Now, it was developed by a San Francisco-based company called OpenAI, which was interestingly co-founded by Elon Musk. They received a huge financial injection from Microsoft to the tune of $1 billion. Now, OpenAI's crowning glory is their GPT-3 algorithm. So what this is it's a massive neural network that's been trained on a vast corpus of text, basically any text they could scrape from the internet. And as a result, it's able to produce some incredibly realistic human language from very simple text prompts. So as an example, The Guardian published on their news website an article called "Robots Come in Peace." They effectively asked GPT-3 to write them an article about the future of AI and how, as the name suggests, AI is not going to be a threat or a peril. Now, Copilot uses a modified form of GPT-3. Instead of training it on lots of text, they trained it on lots of code. In this case, they trained it on GitHub, which is the largest repository of open source code, which again was acquired by Microsoft. And this is where there have been some issues and concerns around whether this is legitimate use of open source code. That's a big can of worms. I'm putting the lid right back on it. Finally, it integrates with Visual Studio Code, which is probably the most popular code editor, again, created by Microsoft. And I think you can see a common theme running through each of these steps. So in simple terms, how it works, and let's keep it really simple, is your code plus codex equals context-specific and bespoke suggestions. So basically, it takes the code that's in your current file in your editor, it sends it off to the codex algorithm. Codex replies and said, I think the next thing this person will type looks like this. So let's have a look at how that works in practice. So this is Visual Studio Code. I've got Copilot up and running, and I'm going to do some very quick programming. So this is JavaScript. Hopefully, most of you will be able to understand it or at least get the gist. So at the moment, I've created a date, and what I want to do is add one day to the date. And here you can see Copilot immediately pops in and completes my code for me. Let's try something a little bit more complicated. Check if it is a Sunday, for example. And immediately, it provides a very logical suggestion. However, this is interesting. Every time you demonstrate Copilot, the suggestions are slightly different. For some reason, randomly, it said, if it's a Sunday, add 2 days. I never asked it to do that. And last time I tried it, it didn't do that either. That's an interesting byproduct of an AI-powered programming pair. Let's try and get it to do something a little bit more complicated. Let's try to write a function that determines whether something is a leap year. So let's go is leap, I can't type, is leap year date. Check if it's a leap year. Okay, Copilot thinks I should write comments. And here we go. Again, okay. It's getting completely distracted by my code above. Let's try that again. If it's a leap year, that's more like it. I'm just going to do a quick format. There you go. That's more like it. It's determined whether a particular date is a leap year. Let's have a bit of fun. Let's ask it what the best programming language is. Is it going to complete for me? Oh, it helps if I could spell correctly. Let's check, see what the best programming language is. And it's JavaScript, of course. Let's try something slightly more complicated. Let's try the kinds of thing that you might do in a coding interview. For example, let's find a palindrome, for example. And there you go. Immediately, it has come up with a very sensible suggestion for how to determine if something's a palindrome. Let's try something even more complicated. Let's try and write a function that takes a number and converts it into Roman numerals, a relatively complex programming challenge. And here you go. It's immediately suggested a really significant block of code, which on the surface of it appears to do exactly what I've asked. And that's one thing that's worthy of note. There are no guarantees with Copilot when you're working with it. The final demo I want to do is show that Copilot, not only can it provide autocomplete based on a few lines of text, it can suggest some really complicated and large blocks of code. So here I've asked it to create a React app that tracks workouts, and I've asked it to display them in a particular way. What I can do is I can fire up Copilot, and you can see in the background, it's currently synthesizing different solutions. And we can see, for example, let's review these solutions, and I'm going to accept that one. We can see that it has written pretty much an entire React app that looks like it probably does exactly what I asked it to, which is frankly quite astonishing. So let's have a quick think about the current state of Copilot and some future thoughts. Some of the challenges that I've found along the way, I'm going to list 3 of them. First, it can be a little slow and you don't know when it will arrive, particularly challenging when you're recording a lightning talk in the space of 10 minutes. Cognitive load. This is probably the biggest challenge that you face with Copilot. My pair programmer isn't always correct. And again, as we saw earlier, it gave an output that I wasn't expecting, even though I have rehearsed this talk. The onus is still on you as a developer to ensure that the code you commit to Git or GitHub is correct. So you cannot rely entirely on your pair programmer. Finally, it feels a little bit like it yanks the keyboard away from me. If you're working with a real pair programmer, a human, they don't immediately take over and start typing for you. There is a two-way conversation between the two. So whilst I understand what they're getting at by calling it an AI programming pair, it doesn't have the richness yet that a human pair programmer would. But this is a preview release. These are early wrinkles, and personally, I can think of some fairly decent solutions to some of the problems that I've already observed with it. The one thing I can pretty much guarantee is that Copilot is going to be big, and I can pretty much guarantee, at least that's my personal guarantee, that at some point in the future, you will find yourself working with an AI programming pair. Thank you very much.
Thank you, Colin, for that excellent talk. Next up, we have STEWART PAVITT, who joined ScottLogic in June as a technical architect. And the subject of his talk is removing opportunities for confrontation in code reviews. Take it away, Stuart.
Thanks, Paul. Hi, everyone. Yeah, as Paul said, my name is Stuart PAVITT. I joined in June. It's been a great experience so far. And yeah, so let's just dive straight into my talk. So when I sort of thought about this talk, I went off and looked at why do people do code reviews? What are the reasons? You know, if you Google why do people do code reviews, these are common reasons. Preventing bugs, fixing coding errors, adhering to standards, following processes, code quality, meeting requirements because your boss has told you to, because the team tells you to, improving performance and consistency. And these are all reasons that people put forward. They're not reasons why I do code review. In fact, because of this reason, if I want to prevent bugs, or to prevent bugs, we test. To prevent coding errors, we use static code analysis. To adhere to standards, we use linters, syntax partners, IDEs. To follow processes, we have work practices. Code quality, we have SDLCs. Meeting requirements, we have acceptance criteria. Everything on that list can be achieved something else. So if you can do that, why are you code reviewing? Well, when I do code reviews with my team and when I introduce code reviews, the only thing I ever say, the purpose of a code review is really simple. It's to share knowledge and understanding. And in the last sort of 2 years when we've all been working remote, there's much less opportunity for face-to-face communication when we're talking to each other. And a code review is a great example of when you can get in the room with your team or a colleague and actually have that interaction and sort of grow relationships by sharing knowledge and understanding. So, but unfortunately, what tends to happen with the tools we have, you know, if we think about the tools, they're set up poorly, incorrectly, and they don't help us build that knowledge and understanding. In fact, they really sort of discourage it. You know, they allow people to sort of write passive-aggressive comments and sort of, or to write comments and they're misunderstood and people get defensive about code reviews. And a code review should not be a defensive exercise. It should be a chance to grow as a team. So when I introduce code reviews and when I do code reviews, what I try to do is I get people to change their perspective. And instead of thinking about bad code and good code, which is binary and it's either negative or positive or what I like or emotional, what I want to do is think about the qualities of code. And quality is a really interesting word. Because when you talk about quality, it can mean many different things to many different people. Yeah, and everything can be seen as quality in a different way. So if I asked everyone listening to think of a quality car, you might think of different things and you have different metrics that decide what you think is quality. Some people will say a Ferrari, some people will say a Tesla. Some people might say, actually, my car's done 250,000 miles. It's went around the earth and it's still going. That's a different form of quality. So when we go into code reviews, if we think about the qualities of the code, it becomes much less emotional and much less emotive when we're dealing with it. So and what it also allows us to really think about is the trade-off in qualities. Because if there's really few examples of bad code and there's just code that exhibits qualities we enjoy, qualities we admire and value and qualities we don't, then actually we can find that balance. So for example, a great example is readability versus performance. If, for example, you're writing a safety critical control system, performance is probably more important than readability. But if you're writing a normal app and you've got a team and people are coming to join your team quite a lot and your team's growing, then readability is really important because that will allow your new people to come in and get you going quickly. You've got purity versus flexibility. We see that a lot in the JavaScript community right now. Abstraction versus concreteness is another example that we've been going through for quite a while, and they all have benefits and they all have trade-offs. Complexity, simplicity, time to develop versus time to understand. That's really important. Yeah. We've all seen examples and we've all heard of examples where code is taking a couple of minutes to write even, and then months later, years later, it's become very expensive to maintain. Yeah. Or it's become very difficult to understand. So there's all these quality metrics we need to consider. The other thing to remember is what you think of quality changes almost every day. Like it tweaks a little. As we evolve and we grow, your definition of what you think is quality changes. So a team needs to find that common balance, but they need to remember that balance isn't fixed. It changes every little. Just because in the Agile Manifesto it says people and interactions over processes and tools, people change, so your definitions change. The other golden rule about doing code reviews to reduce that chance for emotion and the chance for the negativity is to always go into a code review with this in mind. Regardless of what we discover, we understand and truly believe that everyone did the best job they could, given what they knew at the time, their skills and abilities, the resources available in the situation at hand. Basically, think the best of people. If they've done something you disagree with, that's okay. They were the person in the chair at the time. Just always go in with a positive mindset. And if you do that, you will find the opportunities to grow and develop your team increase with your code reviews. So I spent quite a lot of time talking about code reviews and not really talking about how I like to do code reviews and the method. So I'll introduce now. Quite simply, I just do a mob review. I think mob review is the best way to do code reviews. The difference is I have specific rules that attach to it. So I describe a mob review as where code is reviewed by a cross-functional team. And to that, I also include my business analysts, my delivery managers, my scrum masters, and my product owners. If they want to be involved, they're more than welcome. It's an open session, okay? Because at the end of the day, if you're writing code in English and you can read English, you should be able to pretty much understand some of the code that you're seeing. Even if you don't get all the sort of complexities and the symbology, you should be able to understand it. So, but to run a mob review, you must have rules. And these will help you remove the emotions and remove the opportunities for conflict, which are caused. So anyone can run the code review, that's it. Doesn't matter. It doesn't have to be the author or the lead. Anyone should be able to take the opportunity and run the session. The author of the code is never revealed. That's really important, right? Because if the author doesn't get revealed, then they won't feel the need to defend, okay? And again, that's removing the conflict. No one can call out the author either. So nobody can say, oh, John wrote that or Jim wrote that, or it should be completely anonymous. Again, just to reinforce that it's the code getting reviewed and not the person that wrote it. And that's a real segregation we always have to remember, because too often that just becomes the same. The other thing is the most junior member of the mob should be able to articulate the code. That's really important. So we're changing that whole dynamic as, what do you mean you don't understand, to, of course, you have to understand. And again, I value readability over everything else. That's changed in my career. But now readability is the most important thing, and that time to understand. They can't read it or they can't articulate it. It's too complicated. End. That's simple. Next two rules are really important. Bring in developers from other teams and bring in developers who don't know the language. Okay, so if you're code reviewing C#, get a database developer or get a JavaScript engineer to come in and look at the code, right? Because they should still be able to read, understand, and articulate the code even without specific domain knowledge. And what those two things are going to do is it's going to give you a measurement of your time to understand. And that's really important, because if your time to understand is, it could be anything from a few minutes to a few weeks to a few months to even a year. It's every time a new developer comes on, until they're up to speed, and effective in the team, you're burning the company cash, okay? So time to understand is also a really important method of software quality we don't talk about. And again, there's a chance to find a way to talk about it in your code reviews. The other thing is always call out the positives. Don't say, I don't like that method name, or I don't like the way you've done that. Say, I really like the fact that I can see that you've emphasized performance here, but actually, the rest of the code's sort of readability more. Do you think maybe, or I see that you've done a concrete implementation there. Do you think actually an abstraction would allow extension later? And the last thing, which is really important to remember, is the code doesn't need defended. It doesn't care. It doesn't exist. It doesn't have feelings. Yeah. It doesn't care if you like it or not. Don't defend it. That's the important thing. Yeah. We're there to grow as a team and get better. So that's me. So thank you for listening. I hope this helps. If you have any ideas or tips you want to share, please let me know. And thank you.
So next up, we've got Javon Beckles. He's senior developer at ScottLogic, and he's been with us just over 2 years. And he's going to tell us about a really interesting, innovative personal project that he's been working on.
Hi, everyone. In this presentation, I'm going to share what I've learned based on my progress in a personal data project involving cocktails and data science. As I have an interest in both data science and cocktail making, I thought it would be a good idea to create the equivalent of a music playlist for cocktails. Essentially, I want to know which cocktails are good to have in the summer, spring, autumn, and winter, and which can be enjoyed in multiple seasons. This would ultimately help me to stock up on the right cocktail ingredients at various times throughout the year. So before we get ahead of ourselves, I've only really just about prepared my data to pass through a machine learning algorithm, so nothing too fancy yet. What I want to focus on here, though, is how I apply the various data science skill sets to get to where I've reached so far. Hopefully, this will help you to see the importance of being able to pivot among the skill sets when doing data science. Let's take a look at cocktails in general. For anybody who has made a cocktail, the first bit of information you get is a list of ingredients and the method for making it. Sometimes you get the type of glass to use, which is important in terms of how the drink is enjoyed, and in the data sets themselves, the cocktails can be placed into some sort of category, like classics or shots, for example. If we look at the format of the data sets more closely, the way they represent the data is very similar to a recipe. And as we can see from this slide, representing a list in tabular format is a bit clunky, having separate columns for the ingredient and associated measurement of each list item. To a human, this still looks fine. We can interpret and associate the specific ingredients intuitively, but that doesn't really work for machine learning algorithms. They much prefer to have each column representing a specific type of ingredient. For example, separate columns for rum or brandy. So we need to reshape our raw data into a more amicable format for the machine learning algorithms, or in technical terms, extract our feature vectors. Taking a look at the data a bit more closely, the ingredients themselves are not standardized. You can see that some of them are brands, example, Hennessy and Jägermeister, but then some of them are types of drinks, like brandy or amaretto. And we need to account for this when mapping the data into our feature vectors. Another thing we need to be mindful of is the idiosyncrasies of the specific dataset. So for example, in this one, somebody decided that it made sense to put multiple ingredients in one column. An example of this is each dark rum, light rum, with the intuitive meaning to use equal measurements of each ingredient. While this makes sense for the human, when combined with the measurement, we need to handle these cases properly when mapping to feature vectors. A final thing to be wary of in any dataset is silly mistakes like putting the measurements and ingredient data in the wrong columns, which can just be annoying to say the least. So now that we have an idea of the data-specific issues we face when creating the machine learning algorithm input, let's talk about how the other aspects of data science are involved when cleaning the data. Computer science skills are important for all data manipulation operations, including handling multiple ingredients and white space around text. Beyond this, however, you won't get very far without some domain expertise. For the brand type substitution, for example, my main approach was to map brands to ingredients and break down ingredients into their component parts. In theory, this made sense, but in practice, it generated far too many feature vectors and was particularly challenging for liqueurs, which are both alcoholic and flavored. Since too many feature vectors could affect the machine learning model performance, I grouped ingredients by flavor, similarity, and cocktail function. For example, it was important to identify citrus as its own flavor group because of its function in cocktails. But it was equally important to subdivide that into citrus juice and citrus spirits to account for alcohol content. This optimization could not have been performed sensibly without domain expertise. Similarly, in terms of data validation, when double-checking the volume of liquid in each cocktail, I realized that most of the raw data entries for bitters, think Angostura bitters, use ounces as the unit of measure, instead of the admittedly vague dash. Apart from completely ruining whatever cocktail had this misfortune, such an error could only have been picked up with domain knowledge. Once you've prepared your feature vectors, the next step would be to label the data. That is, define the expected output, Remember that for supervised machine learning, you need to give the algorithm enough information about your input and output so it can generate an accurate model. In this case, I want to tell the algorithm, here's a cocktail with these ingredients or features, the input, and here are the best times of the year to have it, the output or labels. Of course, the cocktail dataset didn't come with the seasonal label data, so I needed to add it. One way to do this is to perform clustering with a machine learning algorithm to let the data tell me how it should be grouped based on the input features. Another way would be to use domain expertise to assign my own labels. In practice, a combination of both techniques is used. One, to reduce the burden on the domain expert, and two, to ensure that the labels themselves make sense. My current plan is to use 2 clustering algorithms to get general group consensus and then apply heuristics on top of that. So what did I learn from all of this? Firstly, you need to make sure that your feature vectors and labels make sense to you. If they don't, you're asking the machine learning model to make a guess based on something you yourself don't understand, which doesn't help. Secondly, let the data tell you as much as it can. I found this particularly useful in data verification and labeling. And lastly, double and triple check the legitimacy of the steps you've taken so far. I can't stress this enough. Your model insights are worthless otherwise. That's it from me. I hope you enjoyed this talk and have a better appreciation for the role of the various data science skill sets. Hopefully, you've learned something and you are able to apply this in your own projects.
Thanks, Javon. That talk's made me think about which cocktail I'd like to enjoy after these talks. Now we have Kat Corris, who's a delivery principal in our Edinburgh office and joined us last November, right in the middle of COVID lockdown. So she's going to draw from that experience and give us her tips for a connected workforce in a remote world. Take it away, Kat.
Thanks, Paul. Thanks everyone for listening to my lightning presentation. I hope you enjoy it. I'm just going to talk today about my top tips to keep a connected workforce in a remote world. I don't know about you, but over the last year, I find I really, really miss being with people, working alongside them and thriving off that environment. So I'm going to have a chat today about my top 3 tips to beat the blues, improve the way you work and get that same almost connection with your colleagues. Hopefully this will also get you to think a little bit about how you can experiment with your own working practices. So tip 1, start some new ceremonies. Add a few new ceremonies to your working DNA just to get back some of those missing connections. I thought hard about what I missed, and having a coffee and a chat in the morning before getting started with work was one of those things. So I set up an open invite with my team to have a coffee and a natter before we started work, just as we would do as normal when we arrived in the office each day. It became something that we all looked forward to, so we decided to start ending our day in the same way, with a bit of a check-in and a check-out, a chance to share our stories from the day, unwind and just leave that working day behind, bringing back some of that more natural, organic conversation you miss when all you're doing is scheduled meetings on video calls. I also then decided to start a Friday TGIF, thank goodness it's Friday, where we all joined a video call at the end of the week to give thank yous to each other, celebrate those successes from the week, have some solidarity in the things that didn't go so well, and have that little bit of banter and more organic chat just before the weekend. So bookending your week and leaving everyone with a lovely warm and fuzzy feeling before they start their weekend. Tip 2, and this is a difficult one, is work at your desk, camera on with your team. So take advantage of all the collaborative tools that we have at our hands and open a call in the morning. I love working in creative and collaborative environments, and I find that became a lot more difficult to achieve when working remotely. In my previous role, my colleague and I were the only ones working on a piece of work together, so we experimented and we started working every day with our cameras on, just as though we were sat next to each other. At first, it was quite weird, but we did get used to it. But be aware, you get very close to your colleagues working in this way. We then extended that to the larger team and took advantage of breakout rooms. where we would use those breakout rooms just to split out and discuss particular things and then bring the findings and the outcomes of those back to the wider team. We used some techniques like mobbing to collaborate, or we just sat next to each other. Mobbing was really useful because it was a great way of bringing all of our ideas together, working as a team and bringing back that creativity that happens when you're bouncing ideas off your colleagues. We would be working on sometimes the same things together. Sometimes we'd just be sitting doing our own work and we would just ask our colleagues every now and then, well, what do you think of this? What do you think of that? Do you think this is a good idea? And it really also accelerated our delivery of work and our productivity whilst we were working in that way. Just bringing in these 3 small changes really started to bring back that organic communication. And as I say, we started to bring back that organic communication that really helps drive creativity other than that formal meeting structure that we'd fallen into. Third tip is make it fun. Try experimenting with different techniques and tools to see what works for your team. We played with the Pomodoro technique to help focus and to get the most out of the times that we were pairing with each other. The Pomodoro technique was created by an Italian, Francesco Cirillo, in his kitchen using his tomato kitchen timer, hence the name Pomodoro, where you do 25 minutes of work with a 5-minute break, and after 4 Pomodoros, you take a longer break. We would then take turns doing the driving and being the person with the hands on the keyboard, and it worked well for some things, but we did find it wasn't quite long enough to actually really get something productive completed in the time. So we supersized our Pomodoros. This is a technique created by Nathan Kleitman, and it's based on our body's ultradian rhythm, where we work for 90 minutes and take a 10-minute break. So I found a mix of the shorter Pomodoros for short tasks and the longer Pomodoros for bigger tasks worked really well. And it really helped to keep that focus and also working in that pairing model, doing it that way, keep that creativity and innovation within the work that we were doing. The last part of the third tip is really take advantage of all those different tools that are out there at your fingertips. You have Teams and Zoom with their breakout rooms and the virtual whiteboard, but there's so many other tools you can play with. Tools I really enjoyed working with were Miro, because it's a collaborative replacement for a whiteboard or a post-it note board. So if you're doing team retros, any brainstorming sessions, any sessions where you want to work together and come out with ideas, Miro is a great way of replacing that kind of collaboration around the board. Google Apps and Office 365 are awesome for collaborating on documents. You can work in real time with each other at the same time on the same document. Canva is a great tool to use as well. When I had to create some visual material, it's free, it's easy to use and really fun to work with. So Canva is definitely something I would recommend giving a try. Glide Apps is fantastic for creating reporting dashboards, etc. So really explore the technology landscape and work out what are going to really benefit you. And it makes a change from the usual things like Trello or Jira that you would be used to using in a collaborative way with your team. Embracing all of these 3 tips in this new remote world, I found made a massive difference to my working week. But it also left me with this arsenal of new ways of working that I will definitely keep carrying forward through the rest of the pandemic, and as we come out of it into a phrase I really dislike, but it's very appropriate, the new normal. The big thing I found was that I was much happier at the end of the week, and I felt like I'd had a full rounded week rather than just keeping my head down and producing work. I still felt like I'd had that connection with my colleagues. My productivity increased, as did that of my colleagues, and pairing definitely helped to increase that quality and reduce the effort that goes into creating documents or slide decks and then circulating them for a review cycle. You don't need the review cycle because you've had multiple heads working on it at the same time. The best part of it is it really enabled real-time feedback, and it reduced any waste that we could have created through using less collaborative approaches, given that we're all in separate locations. So that's my 3 top tips. I hope you find them useful. Please reach out to me if you want to find out any more about how I adopted these techniques and the other benefits that I found from them, and to get some other tips from me about other really useful tools that you can use to really accelerate and leverage the benefits that you can achieve using these collaborative tools and techniques in a remote working world. And thank you for listening.
Thank you for that. I hope you'll agree that that was a really interesting talk. Next up, we have Jan Volmert. Jan is a senior developer in our Bristol office and has been with ScotLogic for 3.5 years. Jan is going to talk about an innovative way of using Postman during development work to aid a non-technical audience. Take it away, Jan.
Okay, thank you very much for that. Again, my name is Jan Volmert. I work at ScotLogic, and today I'm going to talk about some ways how to make your API responses more accessible to people who perhaps don't necessarily understand the JSON, but they would like to understand what you've been working on. So let me start at the beginning. In the recent past, I've been working on quite a few projects that revolve around building APIs over underlying data and operations. And sometimes if these days the API will return you a JSON, right? So it could be simple like this, it can be more complex, or usually it's something in between. Now, when I want to test my service, and by the way, if anyone of you doesn't build API services, don't worry, just pretend that you do and go along with that. So again, when I talk to my API service, I like to use curl, or if it's more complex kind of request, I tend to use Postman, which is it's easier to use it for tweaking requests as you go. Now, when I joined my team, I noticed that most of the people actually use Postman as well, which makes it easy to share requests among people. And then I figured out that actually almost everyone in the organization used Postman to do API testing in one way or another. So as you see, the Postman is quite widespread. I don't know if it's the same in the place where you work, but I've been meeting it over and over again. Now, but this is not necessarily important. The important bit is that, and what I want to talk about today is, every now and then you want to show the progress of your work to your colleague or to your product owner. And at that point, you want to sort of take the Postman away and use some sort of UI, be it a web page or something else. Now, the problem with that is sometimes that you may not even own that UI. It may be a different team who you don't have access to. It might be a completely different version to what you have deployed, so it's not compatible at the point you want to show that to someone, or that UI doesn't exist at all, right? It may not have been developed, or it may not even be developed because the client of your service might be another service, right? So, as I said, you still want to show the progress though, right? So what I notice is that people tend to use the same technology that they use for testing, which would be the Postman, right? Be it your colleague who you want to show a particular request and response to test something, or your product owner, or maybe your stakeholders at the sprint review at the end of your iteration. Now, usually what I notice is that the audiences of these at these meetings are of few types, right? Sometimes they are fairly technical and they are okay with JSON, and they generally try to break your API by saying, could you please try this special character, or could you try this SQL injection? And I love them for that, and this makes the demos quite interesting and interactive, right? Then there are people who understand the sort of this concept of request response. They've seen JSON before. They are generally okay with that, not necessarily 100% familiar with it, but they can roll with that. And sometimes people just don't know what the JSON is, and that's absolutely fine. This would be business people who just don't necessarily care about your services and what it returns to your UI. They care about what the functionality is, and that's absolutely fine. So using Postman to show them something about your service, it doesn't quite work. And I've been actually in that situation recently where my product owner said, well, could you please make this demo for the panel of business people? It's really important that we make a good impression. And I was like, yeah, sure, I can 100% do that. And they said, oh, it's in 2 days. And I was like, I've done this demo in the past, so I'm quite okay with that. And then they said, yeah, but they don't understand JSON. You can't just show them, you have to figure something out. And that was not good, because essentially that was all our service was doing, right? It was collecting data and spitting out JSON. So it was slightly more complex than this. It doesn't necessarily matter, and I'm not going to bore you with details of what I've been working on. Rather, I'm going to use a slightly simpler example. So let's say that I talk to my service and I give it a client ID, and what it returns to me would be a list of permissions for the particular client. So you see that there is a sort of permissions array. Photos would be public, so it's set to 1. That means that I'm happy to show it to the outside world. But let's say that my friend list is set to 0, which means that I don't want to share my friend list. So this would be our domain for this exercise. Now, I started to think, right? I want to show our progress to people who don't care about JSON, and they wouldn't really be impressed about that. They would not, and they would walk away. So I was thinking about building a simple UI for that, but my JavaScript is quite rusty, and I don't know if I would build it in time. So I was thinking maybe I should just use the JSON response and just be done with that. But at the same time, I wanted to do a good job of presenting our progress, right? So I started to panic, and then I Googled, I think I put Google something like Postman better responses. And to my great amusement, there actually is a function in Postman that can help you visualize your responses. Now, maybe you are aware of that. I definitely wasn't. In my version of Postman, it was like a demo feature. And not many other people seem to know about it. It seems to be quite obscure, but it lists exactly here this sort of visualize button in your response. So I started to read about it, and I noticed that on Postman's website, there are a few examples about that. They usually present some charts with that, or maps. I think this particular thing is showing airplanes or flying over Switzerland. So I was thinking, maybe I could use this to make something prettier than just JSON, right? So I wanted to. This was my response, or sort of pretended response from my server, and with a little bit of HTML, a little bit of JavaScript, I was able to make it into this. Which, okay, I'm not a designer. It's not beautiful, but it serves its purpose, right? It takes the data and puts it into sort of different view, which might be accessible to the person who we are showing it. Now, this is the end of my slides. I would like to quickly jump into Postman and actually have a look at how this works. So I have a few requests here prepared. Hopefully you can see it all well. I'm going to send this off and get back my response. As I said, there is this visualize button that can make it into whatever you actually want. And the way it works, now, if you are familiar with tests in Postman, this is exactly what you are doing. You write a little bit of HTML here, a little bit of CSS, and a little bit of JavaScript that just puts the data around the page. So I think even someone with not so great JavaScript, not just me, could put together a quick script, and it sort of helped me. And I chose this over UI, like a UI application, because now I can export this, give it to all my teammates, give it to my PO, who sometimes makes requests to our service just to check what happens. And they can immediately see, based on input that they provide, what the service returns in sort of like a visual way. So let's say that someone would change my employment from being public to being not public. I can send off the request and get back different data. Now I see that my employment is 0, and if I visualize it, hopefully, strange, this doesn't usually happen, as it happens during the demo, but I promise you it would show you the, what else did I do that again? There we go. So my employment now changed the color. So it takes the response processing in a certain way. Now let me send off the last request, which actually takes us to the end of our presentation. I thank you very much for this. Hopefully you've enjoyed it. If you know about this, let me know if you've done anything funny with this. Let me know if you will use it in the future. If you do something really crazy with this, like running React and Redux inside Postman, I'll be really glad to hear about it. But no, thank you very much for watching, and I hope you have a great day.
Thank you for that. That was really interesting. Great stuff. Next up, we have Chris Price. Chris is a solutions architect who joined us as a graduate and has been with ScottLogic for more than 10 years. Chris will be talking to us about GPT-3, one of the most massive and impressive AI models to come out of OpenAI. Take it away, Chris.
Thanks, Paul. So I'm going to be talking about GPT-3, how you get, or how you derive creativity from determinism. And don't worry if none of that makes any sense to you. I guess the idea of this talk is to introduce it. So how we're going to get there is we're going to first off cover tokens. So tokens are like the fundamental part of text transformer models. We're going to cover off what exactly a text transformer model is. And then we're going to look at how you introduce creativity to it. So up first, we've got tokens, not transformers. So tokens, I guess an easy way, or the way I think about them, is that a token is to kind of a transformer model, what kind of a word is to you as a human understanding language. So it's almost like that, just the fundamental primitive that the model's working in. So an example of that is if you go and use there's an online tool that OpenAI have there, the OpenAI API tokenizer. You can feed it any text you want, and it will convert that text into tokens. So you can see here, we fed it some text, and it's converted some with a capital S to be 4366, and space text to be the token 2420. It's not so important exactly what those IDs come out as. I guess it's just interesting to note that things like capitalization, things like punctuation, spacing are encoded within these tokens. So it's kind of the fundamental building blocks of the responses the responses and the inputs to the model. If you're anything like me, you'll be interested in, what's the first token, what's the second token, that kind of thing, because I'm sure it's going to come up on a pub quiz at some point. So the 0th token ID is bang, and then you can see that we've also got double quotes, and we've got hash. Interestingly, on the next line, you can see, so they were 0, 1, 2. On the next line, you can see that the sequence bang double quotes is actually encoded as a single token, because you can imagine that's a common occurrence in English prose. I guess any exclamation said by a person is likely to end bang double quotes. But bang double quotes hash is a very unlikely token sequence. So that is that's encoded as 2 tokens. You can see some words are encoded as 1 token. Each of those is encoded as 1 token. Supercalifragilistic is not. Super is encoded as 1 token, but then it starts kind of chunking it up. So you can see it kind of flicks between an understanding kind of like how we have it as humans. So thinking about words as being the building blocks. And then if you get a very long word that you don't understand, you almost start spelling it out in kind of syllables or kind of bits you recognize. So it's behaving in a similar way. The important thing to take from this bit is just that we have a token. Oh, I'm struggling with moving between slides. We have a token, we have a function which is able to take an English string and return an array of tokens. So the model's always dealing in tokens, and it's doing that for computational efficiency. It's not dealing with words, and it's not dealing with letters. So now that we've got that function, still struggling to move on to slides. There we go. Let's talk about transformer model. So let's try and kind of apply those tokens. So if we think about our transformer model as, I guess it's played in this slide by the big black arrow. So our transformer model is fed a sequence of tokens. So we use the tokenizer function from before. We feed a string. and it converts that into a sequence of tokens. That's the input to the model, which we can think of as just a pure function. And the model responds with the token that's equivalent to space time. So very common phrasing in English is once upon a, start of a kid's story. The next word would be time. But then how do you get the model to continue? How do you get it to generate more than one token? Because an interesting feature of the transformer models is that they maintain no internal state. So there's nowhere for it to kind of retain that knowledge of what came before it. And the way you do it is, I guess, with any other pure function, you kind of concatenate the output onto the previous input and then feed that as the new input into the model. So that's how you can kind of build up longer and longer sequences. So in this case, the output becomes comma. So once upon a time, comma. You might not say it, but I guess this is a text-based model. So it's kind of grammar is important. It's learned the grammar rules. We've got kind of we've gone through a demonstration there of generating just the next token, and we generated 2 next tokens. It's much more interesting to put this into a loop, put that logic of kind of taking the output, feeding it back into a loop and run the loop for kind of n occurrences. So that's in OpenAI speak, that's the response length. Or you can run it until you hit a certain phrase that you consider to be the end of the kind of the sequence you want generated. So in the case of a kid's story, I guess that could be the phrasing just the end or something like that. So when it generates those sequences, it'll stop. The important thing to take out of this bit is that the model is deterministic. It's a pure function. You give it the same input, it will always generate the same output. But then that leads to an interesting problem. I guess quite a lot of the examples of these models being used seem to be for generating kind of novel content. So how would you go about generating novel content if it's only ever giving you deterministic output? So yeah, creativity. I guess creativity is just another word for it. It's a very typical human word to use to describe it, but I think it's equivalent in this case. So to talk about how you inject the creativity, I've kind of got to admit that I've been lying to you. When we run the model doesn't just respond with the next token. The model responds with the next token and the probability that that's the next token. But it kind of does more than that. It responds with the entire universe of tokens, the entire universe of possible tokens, so all tokens, and their relative probabilities. Now, don't worry too much about log probabilities. That's just another way of expressing a probability. You can just consider it to be a percentage, as we've done here. So for every time we run the model, it tells us the likelihood of any token coming next. We can make use of that. Oh, load the next slide. There we go. We can make use of that, and we can choose not to choose the most likely token to be the next token. Given that we're in control of what we're feeding back into the model, we can take maybe the third most likely token. So in that case, instead of it being time with a lowercase t, time with a capital T, the third most likely was once upon a midnight. Now, not being an English buff, I had absolutely no idea where that was coming from. Turns out that's an Edgar Allan Poe poem. I think it's The Raven. And the next word in the poem is dreary. So once we start kind of pushing the model down a kind of a path of less likelihood, then it can continue in still giving us the most likely next token, but we've kind of pushed it off into a new direction. And there's different ways we could have done that. I guess we manually chose it in this case, but more commonly you would apply randomness to choose it. So there's 2 ways of doing that. There's temperature, and that's just essentially using randomness to bump the relative probabilities of lower likelihood tokens. There's also top P, which is a slightly more nuanced way of doing it. And as you're applying randomness, if you don't apply any randomness, you're kind of, as you were, it's deterministic. It's the best guess for just the next token. If you apply a bit of randomness, you get a good guess because you're still basing your output on an existing set of knowledge. So you're only tweaking the output. If you apply if you turn it up to 11, you'll get interesting results coming out of it. So creativity is about adding randomness. It's about selecting the less well-trodden path. The final thing that you can do is that you can iterate on this process. So instead of just generating one sequence of n tokens, you can generate m sequences of n tokens and then go back and review them and choose which one was the most likely overall sequence. If you know that one, then that's most likely, despite going a kind of a random route to get there, that's likely to be the most interesting or the most useful kind of sequence that was generated. So essentially, you're generating a few ideas and then picking the best. There's also some additional kind of tweaks that you can perform to stop the model kind of starting to repeat or riff on the same ideas over and over again. And that's in the form of these penalties that you can apply. These penalties are just further tweaks that you're applying to those output probabilities. So now that we've seen how you can apply randomness to the deterministic model output, and we can see that that's kind of creative, I guess, what can we take away from it? Well, first, and this is something that I found kind of deeply reassuring. I think when I saw the models originally, I saw how big they were, how vast they were, how complex they were. And I saw that they were generating kind of novel content. And that kind of spooked me internally a bit, because these are meant to be kind of cold, unthinking machines. So how are they generating this novel content? Where's that coming from? But actually seeing that the models themselves are deterministic, they're not thinking, they're not being creative in that sense. That was quite heartening for me. Like I quite like the fact that these models are deterministic. But then I guess I started getting interested in exactly how they were applying that creativity. And I guess it's that breakdown that we've covered in this talk. So creativity starts with a comprehensive understanding of expectations. So I guess that's during training, the models picked up that understanding of what the kind of human expectation of the next word is. We then kind of instruct the model or configure the model or put an algorithm around it to cause the model to choose a less well-trodden path within those outputs. And then we basically repeat that process. It requires a bit more effort to repeat the process, but we can ultimately improve the result by generating a bunch of ideas and then selecting the best. And I really liked that when I first thought about it. I was like, that's really good. That means that we can, that's how you take something that's deterministic and kind of apply creativity to it. But then thinking a little bit more about it, it spooked me, because what we're talking about there is that's not specific to an AI model. That's what we've got there could readily be applied to any kind of human creativity. That's not solely in the domain of the model. So actually, that spooked me and left me thinking, are we actually just computers ourselves? Is that what's really going on? Is that the deeper meaning? And with that philosophy, I'm gonna park it. So thank you for listening. You can read more about the OpenAI models, how they work, and how some of the later kind of JavaScript codex models work on the blog. I'd recommend watching the computer file episodes from Robert Miles on these AI models. They're very good, and he's got a very good channel himself. And I'd of course recommend that you go and kind of sign up for the OpenAI beta and have a play with these models yourself. Thank you very much for listening.
Thanks, Chris. That was really fascinating. It just remains for me to say thanks to all our speakers. Thanks to you for being the audience and coming along and watching this. And if you'd like to follow up with ScottLogic at any point, you can find our website at www.scottlogic.com. And I hope you've all enjoyed that and got something out of it. I know I have. And just finally to say thanks again and goodbye.